Good afternoon at Caltech. I'm Harry Atwater, and I serve as Division Chair for the Engineering and Applied Science Division here at Caltech. And I want to welcome you to the 2024 Woke Lecture. And what we're going to be doing today is having a discussion about the energy transition and particularly the role of the electricity grid with two engineers and of course our third actor here on the podium here, which is the Whiteboard, Reimagining Clean Energy Systems. So I want to first introduce our participants. And first is Dave Welch. Dave Welch is a scientist, an engineer, an entrepreneur, a businessman who developed as a pioneer in optical devices that enabled telecommunication networks. He was his work from his research made it possible to develop pump diode lasers for the optical communication networks that we use ubiquitously today in our data and communications transmissions. And his work also led to the first commercial optoelectronics integrated circuits, well ahead of competition. He entered college at age 16, and went on from the University of Delaware as an undergraduate to Cornell University. He became in various technology and executive roles, rose to be the CTO and vice president of Spectre Diode Labs, whereupon his work in pump diode lasers was carried out. And he moved to CTO of JDS Uniphase, and later transitioned to form his own company, Infinera, which is a predominant optical networking company. And his work has been cited by a number of honors, including the Adolf Lohm Medal which is one of the Young Pioneer Awards of the Optical Society, the Fraunhofer Award also from the Optical Society, the Tyndall Award of the Optical Society, and finally recognized by election as a member of the National Academy of Engineering in 2016. So Dave Welch. Thanks for joining. And also joining us today is Pedro Pizarro. Pedro is President and Chief Executive Officer of Edison International, which is the parent company of Southern California Edison and operates as an operating company for many utilities around the United States and is essentially one of the nation's largest utilities. So a true expert on the utility grid and all of the ways in which it operates and the challenges that it will face as we go through the energy transition. He's a member of the Edison Board of Directors and has served as president of Southern California Edison and Edison Mission Energy. And before that was a manager at McKinsey, coming into the energy world. He earned his PhD at Caltech after earning a bachelor's degree at Harvard University, and has served not only in industry, but also served the nation as a member of the Secretary of Energy's Advisory Board and working groups for the Governor of California on business and jobs recovery. So let's welcome to the stage Pedro Pizarro. Thank you, Pedro. So thank you both for joining us today. And our task really in the next 45 minutes is to reimagine the energy system for the country. And we're going through a period, probably one of the most innovative periods with regard to the energy system since the founding of the energy system, or the building out of the energy system in the late 19th century and early 20th century in the United States. So I guess I'd like to ask Pedro maybe to start with give us a little bit of Grid 101 and tell us what we can look forward to from your eyes to see, California's energy transition from now as we look forward towards 2050.
Great. Well, Harry, thanks so much for having us here. And let's try Grid 101 really quickly.
Great.
Historically, big power plants, a few dozen of those, big wires, transmission wires. By the way, the transformation for that, those high voltage transmission, some of the earliest work for that was done right here at Caltech in partnership with Southern California Edison. That goes down through transformation to little wires distribution and ultimately serving end use customers. That's the way it's worked for a long time. Our company's about 138 years old. What's changing now? A few things. First, much more distributed power, right? And so this idea that it's a one-way transmission distribution network is being upended really over the last couple decades, 3 decades, by increasing amount of distributed energy resources. Rooftop solar is a good example of that, but there are others. What else is changing there? California is a state that's very deeply committed to achieving net zero greenhouse gas emissions, right? And that's an existential issue for humanity, so I'm glad that the state is leaning into that. I became CEO 8 years ago. One of my concerns then was that the state was very progressive in all these policies, but nobody had really looked at how it all fits together. And could you actually do this across the economy and not tank the economy?
Yeah.
And so
Big challenge. Yeah.
Well, it's absolutely, it'd be pragmatic about this. So we began doing analysis back then. We put out a number of white papers. Our last one came out a couple of weeks ago for Climate Week in New York. But let me give you the 201 version of what we think the system will look like as we go in the future.
Great.
And so we see the need to add a significant number of renewable energy resources along with storage to have a clean supply of electrons, a low carbon, ultimately net zero supply of electrons. And so that means going from a system that today might still have a lot of natural gas plants in California, in other states you still have coal plants, continue to see a diminishing of those, and the additions we see to the system will be renewables, whether solar, wind, hydro, geothermal, et cetera. Balancing those with a lot of storage. So today the CalISO, the California Independent System Operator system that governs about 80% of California, probably has something like 80 gigawatts or so of total supply, available. We see needing to add something like at least 100 plus gigawatts between now and 2045, mostly large renewables for that.
So in addition to transformation, huge growth.
A huge growth.
Yeah.
In addition to that, we see a needing to add something like 30 or 40 gigawatts of storage because a lot of the renewables are intermittent, and so you need to store the power for when you need it.
With all of these new forms of generation.
Absolutely. It's that balancing. You need that shock absorber in the system. And then we see needing lots of energy efficiency, so doubling of energy efficiency, going from, and see what light bulbs we have here at Caltech. Hopefully they're moving to LEDs, right? But it's those energy efficiency sort of measures. And then using that clean electricity to repower a lot of the economy. So by 2045, we estimate that 90% of passenger vehicles will be electric. 95% of buildings, space and water heating will be electric. And that'll be a big part of the equation. Not everything will lend itself neatly for electrification, so we'll still need some clean fuels for things like heavy-duty, long-haul transport or high thermal input industrial processes. And for those fuels, like clean hydrogen will be a part of the equation. And then on top of all that, we'll need negative carbon mitigation, so carbon capture and storage.
It's going to require even more capacity.
Exactly, because that will allow some fossil fuel use to continue. When we put all that together, Harry, and we look at not only what will it take to keep the system reliable, but also most affordable pathway to get there, we still see California getting maybe between 4 and 5% of its electrons from natural gas resources. But those emissions and other remaining emissions in the economy being offset by something like 70 million tons of carbon capture. And to frame it, today, I think total carbon emissions in the state are probably something like around 430 million tons a year.
Yeah.
So that's our view of how this all fits together. The paper we put out last week, updated analysis from or a couple of weeks ago, updated analysis from a year ago. In the meantime, we can get into this later. We've seen expectations of load forecasts go through the roof, right? Because we're seeing a lot of electrification along with data center load, et cetera. We are seeing that it is very hard to build new resources. Partly it's something like 15% of the resources we'll need will come from new technologies that are not mature yet, like next generation geothermal or clean hydrogen or gas with carbon capture attached to it, or nuclear, right?
So we have to not only figure out how to build those plants, but how to certify them.
Exactly, how to go through that whole maturity period, how to bring the cost down, and then importantly, siting and permitting is just impossible, right? So it takes 10 to 12 years to build a new transmission line just about anywhere. And so we need government reform to speed all that up. But I'll leave you with this thought. We need to get all of those things working to help the economy get to net zero in California. We're the world's 5th largest economy, so that's instructive for other economies around the world. And then you might be asking, well, that sounds expensive. And yes, there's a lot of investment needed. We think around $325 million or so just for, actually more than $375 billion in California, just for the renewables and storage and the grid to serve all of that. And we think that the grid will need to be added at 4 times the rate that it's been added historically for the transmission wires. But here's an interesting punchline that we didn't expect at first. When you run through all the math, and you realize that the electric applications that are replacing fossil fuel technologies, like or my current electric car, when you compare that to my old gasoline vehicle, those are so much more efficient from a physics, energy in to work out perspective, that we expect our average customer in Southern California to spend 40% less on their total energy bill by 2045. They'll spend more on electricity, they'll be using more electricity. But that total bill of electric plus gas plus gasoline will be 40% lower than
that so-called well-to-wheels ratio
exactly.
will go
And
way
if you
down.
look at what percentage of their wallet they're sending towards energy bills, it'll go from about 7% today to 3% in 2045. So this transition can be clean, can be about net zero, can lead to better local air quality, and also better economics for the consumer.
Yeah, so amazing what happens when you pay attention to energy efficiency.
Yeah.
Right.
Because that might have been 101, 201, and maybe 302 in there. I don't know.
All right, we're on our way to our graduate degree here, I think, but yeah. Okay, so Dave, so you've grown up in seeing the world of optical networking flourish and become the backbone of global telecommunications. And now we're seeing the growth of data centers and AI, which of course have optics in them, but they're also tremendous, they're growing very rapidly, they're fueling all of our demand for data and communications, and they're also one of the most rapidly growing areas for energy consumption in the economy. So give us a perspective on the impacts from computation and data centers, how that's going to change this mix of electricity supply and demand.
Yeah, so I think it adds a really fascinating dynamic, and if you go back for a few years, me personally, the parallels between the data networks and the energy networks have so much in common, whether it is load balancing on your network, whether it is regulation that governs I have to supply data or energy to my farm, the local farm, rural areas, or to my urban areas. There's so much that parallels that. What happened in the data world is the cost of data, gigabits, dropped 25% a year for 30 years, right? And in the consequence of that economic decline in the core element, the volume picked up, and it really enabled data centers. It transitioned the world from the busiest time on the telecom network from Mother's Day, which up until probably 98, 99 was the way they sized networks.
Calling your mom on Mother's Day.
Calling your mom was the most data consuming network application, to where then data centers completely overtook. It was the machine-to-machine interactions that went on, and that it was the price decline that enabled those applications. And it first went through all the various stages, and the latest stage now is the use of AI. Right? To give you an idea, a singular Google search today consumes some amount of power. I got to forget the specific number, but it's the single AI search, the single chat GPT search consumes 10 times more energy.
0.3 watt hours versus 3 watt hours.
Exactly,
Yeah.
right. So it's a 10x increase in that application space, and the more you use ChatGPT or AI-like applications, the more you realize Google searches are antiquated. They just don't give you the information you need. And so you have it going through the next phase where I need to have, I am in a supply-constrained growth mode. I need energy, right? I need energy to happen. And so there's this interesting dynamic because it is one of the largest growth sectors in our economy, and you can see it in the valuations in NVIDIA, or you can see it in whatever, the overall economy and where the investments are going, that is the next economic goalpost for people to go after. But what's in its way is the development and the deployment of many, many more data centers, much more than what's already been deployed. And where these two market sectors intersect is they need energy. So they have to do two things. They got to figure out how to make a data center that is dramatically less power consuming, and they'll work on that. And there's lots of technologies that we employ. But at the same time, they need to figure out how to interface with the energy system. And so now here comes an interesting question is the grid as an element is, in my mind, is the most beautiful commoditizing market for energy, right? Once I'm in the electrical realm, I don't care where that potential difference came from, right? And so whoever can put electrons or potential into that grid the cheapest is going to be the element that gets deployed. And so you're looking at, I was looking at a chart earlier. It depends on who you listen to, but there are several people that predict a major growth in energy consumption. And if that can only happen if the cost of the supply drops. And if the only way you could ever achieve that ends up being clean energy, then you're going to go through a complete rapid adaptation of clean energy sources to take advantage of this economic growth that's pent up waiting for new AI deployment in that process. And the transitions can be quickly. One of the numbers I was looking at earlier, the fraction of new energy put on the grid that is clean right now, especially in addition with support of the IRA, I don't know what it is, but it's a huge fraction of newly capacitized energy is going on is clean. That may be artificially supported for some period of time, but the trend is gonna continue to grow. Yeah.
Yeah, so we're going to have growth of, it seems irrepressible that humans are going to use more computation, they're going to use more of the world's knowledge aggregated in the form of machine learning searches, much more energy intensive, fuels electric demand, fuels competition for clean electrons, really, among other things. And yeah, so we're seeing capacious, rapacious growth for electricity.
Yeah, we can give you a number on that if it'd be helpful.
Yeah.
Right? Just 2 years ago, the 5-year forward forecast for load growth across the country was something like 2.6%. Got redone earlier this year, it was 4.7%, so it almost doubled. For Southern California Edison, they do a 10-year forecast. The version from 2 years ago versus the one today, 35% increase. And it's not just data centers, but it's also electrification. That's actually the main driver in California, with 25% of new vehicle sales here having a plug versus 9% nationally. It's data centers, of course, but it's also other bills working. You mentioned IRA, Dave, and you're absolutely right. But also think about the bipartisan infrastructure bill, the CHIPS and Science Act. They're bringing manufacturing back on shore. And you don't see as much of an impact in California from that because we're a higher cost state. but there are states where my colleagues are seeing 8% load growth.
Yeah,
And this is
Arizona,
an industry
for example.
that really had been flat in terms of load growth for the last 3 decades, something like 0.5% a year. So you jumped up from that to 4.7% and maybe more.
Yeah, so 2 to 4% in that demand growth is growing faster than you can commission and deploy projects. And
Which is why you're seeing more projects being announced. You're trying to build those. Siting and permitting, again, is a challenge. You're seeing projects that frankly might have been unheard of 5 years ago, like 3 Mile Island coming back. Right?
yeah,
And importantly, you're also seeing the delay of the retirement of resources. So, Dave, you're right, significant additions on the renewable side. But at the same time, across the country, you're seeing a push for delaying some retirements of fossil fuel plants just because you have so much need for power. And the paper we put out a couple of weeks ago, one of our big punchlines there is that if you look at 1 gigawatt of clean, firm resources, say advanced geothermal that can deliver 24/7 or gas with carbon capture or the like, 1 gigawatt of that gives you the same emissions reduction power as 7 to 11 gigawatts of solar paired with storage.
wow. Okay.
Right? So just think about that for a minute. We need them both,
Yeah.
right? But that leverage that you have by developing clean firm is powerful. In the meantime, until we can get these resources to mature and get them deployed, we're saying California can't retire any more natural gas because we need that insurance policy. Hold on to it, and we don't have a dog in the hunt. We don't, we don't sell gas. We just want to see a market out there that has resources
And it has stable capacity to meet energy demand.
Exactly.
Yeah. Okay.
Yeah, if you believe the need to trade out old infrastructure for new infrastructure, the fastest way to do it is to take advantage of a market that's growing. Right?
Yeah.
When the market is flat and stable, infrastructure doesn't get traded out. So it's actually the embracing of this high growth opportunity that feeds itself, that will end up driving the necessary, added increment and the added differential cost benefits that can come with that energy. If we don't embrace actually rapid energy growth, then you're going to see a slower adaptation to cleaner energy.
That's right. So Pedro sees rapid electrification of huge parts of our existing economy, demand growth. Dave sees data centers really changing our lives, but also changing our energy consumption habits. One of the things I see from where I sit is that we will also see a revolutionary change in our fuels, chemicals, and materials industry over the next 30 to 40 years. And so I'm going to introduce here the fourth member of our panel here, the Whiteboard. And so I'll just start to note that since 100 years, since the end of the 19th century, we've had a fuels and chemicals and materials industry that started with raw materials down here, like naphtha and kerosene, and then methane. And these are feedstocks that come from coal, gas, and oil. So down here we have coal, gas, and oil. And then there was a little bit of hydrogen that we use as a feedstock in today's chemical industry. But that's basically it. And then that drives all the end applications in plastics. So up here we have applications. And here we have feedstocks. And then we have plastics, pharmaceuticals, rubbers, insulation, fuels, things like tires, all huge amounts of polymers and chemicals, and lubricants, and then and basic fine commodity and fine chemicals. And in between, we have a layer of things like ethylene. So we have and these are what are called platform chemicals. And we have ethylene, propylene. Ethylene goes through and we make polyethylene to make plastics or plastic bottles. Propylene, butene, C4 products will have 4 carbon molecules, aromatics that allow us to make things like kerosene and jet fuel, and then finally over here, methanol. And so really, so what we have now is an industry where we take coal, gas, and oil, and we make all these things as feedstocks. They get turned into these platform chemicals. And these are these big, huge chemical plants in places like Midland, Michigan, and the Texas Gulf Coast and places like this that do this, that now create all these end products. So what we're going to need, of course, is we're not going to use these things to drive our chemical industry in the future. We're going to replace these, and that means we're going to replace these feedstocks too. And as we go towards 2050, and we have electricity, we have clean electricity. So what are the other chemical feedstocks we need? We're going to use CO2, we're going to use water, we're going to use hydrogen and nitrogen, okay, to create all of those things. And so these, and by the way, these have the greenhouse gas equivalent of these, this is greater than a gigaton of greenhouse gas equivalent. Similarly for propylene, rubbers, aromatics, and so forth. So, we're talking about things where the footprint of each of these end-use elements that comes from each of these platform chemicals is something like the greenhouse gas emissions of a country like Japan or India. And we're going to have to now use these. And so interestingly, I told the students, one of the things that I foresee is we're going to actually have a shortage of CO2. Right now we worry about excess of CO2, but we're going to eliminate, if we're successful in making this energy transition, we're going to have to find CO2 in dilute sources from things like carbon dioxide removal as a feedstock to make all of these other things. But this is going to also generate tremendous demand in the economy as well for electricity, clean electricity that comes from non-fossil sources. And the other thing that's interesting is that some of these processes may not require as much storage as we have now. So you could imagine some of these processes actually operating with capacity factors that are a little lower. You have to be careful with the economics, but they may be able to accommodate intermittency of demand. So this is, in addition to all the other things, we have to think about how we're not going to stop making chemicals, and we're not going to stop making pharmaceuticals and rubbers and plastics and so forth, but we have to make them in a different way.
So the interest, to go to my economic model here is, and you can correct me here, but wholesale pricing, if I'm a data center, I'm going by wholesale pricing. I don't know, let's call it 5 or 6 cents a kilowatt hour, wholesale pricing. What would happen to that industry if it was half a cent per kilowatt hour, right? Because it is the adoption of completely new processes that today we don't pursue because they're too energy intense. But if the price of the energy, and therefore usually I correlate that with the source of energy, is aligned, well then you can go make all these transitions.
I'll give you a good example that if we had half a penny per kilowatt hour electricity, we would be able to do things like replace in worldwide shipping bunker fuel, heavy bunker fuel, with methanol, e-methanol, made from captured CO2 and electricity. In fact, Maersk, which is the world's largest shipping company, is now retooling a portion of its fleet to be dual fuel, which is They have to be able to still operate on default bunker fuel when that's the only fuel that's accessible. But they also have an engine that can, in a number of the ships that they're building now, which will be able to run on e-methanol.
Right.
You know, I think, Dave, you make a really excellent point. I would add to that, though, it's not just the price of the power, but it's the availability, the locational availability of that power. Right? Because when you think about a chemical plant like that, unless the technology for chemical production also can become more distributed, typically you have, for efficiency, these very large-scale industrial processes, which means you need a lot of power in one location. And so it's not just about the wholesale power, the cost of producing the electron, but then you also need to worry about transporting the electron to where it's needed. And that's one of the things that I think often people misunderstand, right? Even if you think about it at the retail level, with distributed generation, rooftop solar, big debates about that. You know, we think rooftop solar is going to play a huge role. It's already on about 11% of our customers' roofs. We think by 2045, we'll see it on half the roofs, right? And that's going to add about 30 gigawatts of power capacity in California. Let's say, you know, we think it's kind of hard to get to 100%, but let's say we got that wrong, and you can put it on every rooftop. That's 60 gigawatts. Terrific. We see, to electrify the economy, an overall need of more, like I said earlier, 100 or 120 gigawatts of resource additions, right? So it's not just the cost, but it's also, can you get it at the volume and scale you need in the locations where you need it? And right now, as we electrify a lot of the economy, we're seeing more and more concentrated loads. Not just, you know, chemical manufacturing, but think about a big depot for electric trucks, right? That's a very concentrated location. So that's another part of the equation.
Yeah, well, I think ultimately and this is why I find the data center thing so fascinating to watch, is I'm a data center today. The philosophy has been, I'm going to sign up to the grid and I'm going to build a backup. Tomorrow, I'm going to build my own power and I'll hook to the grid as that best case my backup. Right? It'll never be able to. And this whole move, I find it shocking that if you mentioned it, the fact that Microsoft is looking at buying 3 Mile Island, I find is just mind-boggling. One, there is enough economic incentive to resurrect the country's worst nuclear disaster project. They operated it for a while, and I don't want to focus in on the aspect, but there is enough economic value to Microsoft to justify doing that. That's a huge statement on how they see the market playing out of growth. And so there's the data center needs to become more efficient. I'm not proposing that, but the economic growth that can come and then that can enable the adoption of next generation energy sources. You have to have that growth in order to be able to really take advantage of next generation technologies.
Dave, I would add to that, I think one of the unanswered questions out there is, as you make data centers more efficient, what really happens, right? As you continue to drive down the cost of that compute
They get
power,
bigger.
Are you really, are you bending the curve down, or are you unlocking more opportunities across the economy to use that power?
100%.
And therefore you're putting the curve back up, right? So it's not clear to me what the reaction of the economy is to cheaper and cheaper compute power. I suspect that in the end, it may bend the curve down a little bit, but it's still an increasing curve. It doesn't go back down.
I can tell you what happened over the last 30 years.
Exactly.
In 1990, the largest companies in this on the stock market were Exxon, Mobil. They were Philip Morris. They were consumables, fuel, cigarettes, and there's probably AT&T in there. Now they're data and Berkshire Hathaway, right? It's a complete transformation over.
Berkshire doesn't count. It's
an investment firm.
It's a conglomerate.
Yeah, and it's an investment firm. But the economy took advantage of the growth in data, and they absorbed it to become more efficient and more valuable in that process. And it absolutely would continue along that way.
So Dave, following along that line, you've had a career that's taken an arc from research, graduate school, technology and solid state devices and so forth, and then really into telecom and then into venture. So how does someone that followed that arc, including the venture part, look at the electricity market? And we talked about this huge demand growth, and how are we going to satisfy that? And what are some of the ventures that you see that can address this?
So it was who was the guy I was talking to? He was I had dinner a week or so ago with he's a professor at Stanford, and my apologies to him for not jumping on his name. He was third in line of the DoD. He was on Obama's daily security briefings. Huge, great visibility. And he affirmed what my belief is the three biggest transformational markets: AI, pharma, and energy. Those are the three biggest markets that over the next 30 to 50 years, from his perspective, and frankly from mine, that are going to go through a remake in that process. And because the societal benefits that come from it. Whether it is the use of AI to develop the appropriate personalized medicines to go address everyone's individualized malady in there, or whether it is the ability to transform and become actually a greater utilization of energy to advance our societies. Right.
So, Pedro, one of the things that we've talked about is the huge demand growth for electricity. That demand growth is being driven by growth in the economy, growth in innovative and disruptive technologies like AI. Shout out to Caltech's John Hopfield, who won the Nobel Prize today for his work on neural networks that led to the work on AI. But of course, another thing we have to confront is that the climate is changing, right? And we have to be able to be resilient, not only resilient as individuals, resilient as societies, resilient in terms of our infrastructure. How do we balance this, and how do we get to this end state of an efficient, electrified, renewably powered network that powers the world 30 years from now, but it's also resilient? I mean, how do we value that too? How do we value the resilience?
Harry, that's a really important question. And when you think about it, all of us view electricity today as an absolute need, and it hurts if it's not available, right? Imagine a world where we are getting, again, 90% of our vehicle movement fueled by electricity, 95% of our buildings being fueled by electricity. It becomes even more essential.
Yeah, suddenly the power goes out and disables everything.
Exactly,
Yeah.
everything goes out. And so the industry is very focused on resiliency. One of the partnerships we have is with the Electric Power Research Institute, which has a 5-year project right now called Climate Ready. It is, actually doing some work that we've already done at Edison, but taking a look at what the global climate models say will be some of the key climate impacts in different regions of the country, and then thinking about what kind of hardening of the electric infrastructure will be needed for that. Sadly, in California, we're ahead of the curve. And I say sadly because sadly we've experienced climate impacts earlier than many other places.
Wildfires.
Right? And so with wildfires in the last 7 years, we have had to redesign how we think about the grid in the 27% of our 50,000 square miles that are high fire risk areas. And so we invested billions of dollars in things like changing out bare wire for insulated wire and putting in new equipment and new monitoring and whatnot. And it's driven the risk of our infrastructure starting a catastrophic fire down by 85 to 90% in those 7 or 8 years. But that's our industry. One of my biggest concerns is that there's a good news piece here that there is much greater consciousness on the need to invest across the economy to address climate change mitigation, right? How do we bend the curve? How do we keep global average temperatures from increasing by more than 1.5 C, might be more like 1.8 C now. Hopefully it's not 2 C, right? A lot of emphasis on that. Probably most of the venture capital that you're seeing, Dave, is flowing towards that in the clean energy space. My concern is that we know that there is a climate change curve that is locked in and it ain't going back, okay? We did a white paper about 3 years ago looking at climate adaptation needs just for California. And the global climate models, when you look at what they mean for our region, say that we're gonna see almost a meter of sea level rise on average by 2050. We're going to see 20% more risk of wildfire ignitions exacerbated by climate change. If you look at the top 1% hot days today, they'll be 7 times more prevalent and hotter by 2050. We'll see more floods and more droughts, not at the same time, but close to each other. And so my big concern is that as a state economy, as a national economy, as a global economy, nobody is putting our collective arms around that problem and asking the simple question, what kind of capital investment is going to be needed to harden the global economy to deal with the climate change that's locked in?
Resilient. Yeah.
So I'm having, I mean, it's like my soapbox thing. I've now talked to, for example, the CEOs of the major ratings agencies, because I think this becomes a big credit ratings issue globally.
Yeah.
Talk to government leaders. We need to put more emphasis, and I'd encourage the academic community to think about how can you help to size up the quantum that will be needed and the kinds of investments that will be needed across all the critical sectors in the economy.
Well, that really leads into my next question, which is, you know, we have here scientists and engineers that are thinking about where do I go in the future with my career, and yet we're describing a whole bunch of challenges. And so, what do you see as being the opportunities that scientists and engineers could have, and you know, either in innovation of technologies, developing resilience, models that can help make things more predictable and, in some sense, adaptable. So, Dave, maybe take a crack at that.
Back to my earlier point, the opportunity is endless. It truly is. And the ability to, the growth of understanding with our AI models and whatever is truly amazing. I like to learn more about pharmaceutical development and brain development, things like that. The level of understanding that we are developing in the medical arena, I think, is incredible. So I think any of these computational methodologies to help better understand what society's issues are going to have a big turnover. You know, go back to how to develop the models, how to apply them into pharma or related things, how to create the both the capacity on the network but the resiliency, which is where also these models end up playing a big role. I mean, and this is area I applaud you because, you know, when we first started getting to know it, one of your main agenda items was to make sure that machine learning was fully integrated across the curricula here, and it's absolutely the right key element of the solution set. Mm-hmm.
I think from my perspective, I'm really grateful for my own career trajectory. Wouldn't trade it, but it'd be fun to be 18 again, right? Because there's just so much opportunity. Yeah. And so think about, I'm just gonna do a random scattering of things that would be very cool for folks who are starting out. Think on the chemical side, and say, you know, I got my PhD in chemistry here. Just the idea of new alternative chemistries for storage, right? And there's a lot of work going on that right now, but you know, that could be a big part of getting to the ½ cent per kilowatt hour. New technologies, like actually the work that's been going on at Caltech for quite a while, through ResNet, through the liquid sunlight, work, different technologies for capturing photons and converting them to electricity or to fuels, right? Because fuel storage, that'd be a great vehicle. Fast forward to, you know, you mentioned this already, Dave, but the advances in computing, and not just AI, right, but quantum and, you know, digitization of the economy, digital twins, cybersecurity. I can't tell you how much of my personal time I spend worrying about cyber. I have a son who's a budding researcher in cybersecurity, is so needed. Go on to, we're talking about the kinds of investments that will be needed across various sectors of the economy. You point out pharma appropriately, but I'm on the board of 3M. I love the discussion on chemicals. 3M is looking at, how they do things more sustainably across their entire value chain. And then I'd say, innovations in other fields. Some of you who might be getting PhDs now or getting science or engineering degrees, undergrad degrees, might actually decide at some point that you want to do something assisting, supporting science, but not maybe directly as a scientist or an engineer. Think about finance, right? The innovations we will need in finance, because that issue I talked about earlier of how the global economy has not sized yet the investment need just for climate change adaptation, we're going to face a competition for capital globally. There'll be more capital needs than capital to be placed.
We're going to have to deploy it wisely.
Exactly. And so innovations in how you think about capital formation and capital deployment will also be a part of the equation. So, I don't know, to be 20 again.
Okay, good. Well, so let's open it up here and take some questions from the audience. We saw a hand up right here. Do we have a microphone?
I think
Okay. My name's Aaron Fike. I'm with Inline Capital, a VC fund that invests in energy. I'm curious about the bottleneck that's literally a bottleneck, which is the interconnect queue. Just to give you some example, PJM is roughly 180 gigawatts, and the queue is currently 160 gigawatts. So there's another PJM sitting in the queue before we do. Pennsylvania, New Jersey, Maryland, great is what PJM is. Anyway, but that's not unique to them. And so there's talk of this the supply growth curve with the bottleneck of interconnecting in the first place. That seems like a huge issue that's constraining growth, and I'd love to get your thoughts.
So for the online audience, I'll just repeat the question, which is that are bottlenecks constraining the ability to meet demand from load growth?
Yeah, and so the one specific, and maybe the decoder ring for folks who are not as close to this, when you think about how you bring new resources online, like a renewable resource, you need to connect it to the grid. Different markets across the state operate differently, but many states are part of organized markets. So California has its California Independent System Operator. Aaron talked about PJM, which has the Pennsylvania, New Jersey, Maryland area, and more than that, it goes actually to Illinois and other places. These are organized markets, and so they basically manage the access to the transmission system to make sure it's open access, to make sure that a utility that has generation and has transmission lines can't be favoring its own generation. So that's what that was all about. To get access, if you have a new resource you're building, you have to sign up to get interconnected. And there's studies the operator needs to make about what will it mean electrically to add this? Do we need new transmission lines or upgrades, et cetera? And so there's a queue for that. And to the point of the question, if you look at any one of these markets, the number of resources lined up waiting in the queue dramatically exceeds, usually probably a multiple of 2 or 3, the actual size of that market today, or even the potential needs over the next 10 or 20 years. So the queues are jammed. I feel badly for the engineers who are having to crunch their way through those queues, because there's just a stack of applications that they need to go through. They put them in queues so that they can do them in batches. And one of the big topics in the industry right now is queue reform. So how do you help those engineers crunch through that math a lot more quickly? How do you also then put in, frankly, tougher requirements for people who are getting in the queue to show that they have a real project and not just a piece of paper? And so that can be requirements around, do you have a permit for a site? Or are you willing to post credit or collateral, to back up the project to show that it's real, there's some money behind it. So these are some of the innovations that are working their way through right now, but it is an issue really globally.
Yeah. Okay, so before we go back to the audience here, we have both an online and an in-person audience, and I'm going to ask Dr. Neil Fromer to at least pose one of the online questions.
Great. Thanks, Harry. There's been a robust discussion online. Hopefully you guys were able to scan the QR code of several of the people in the audience, as well as folks listening from afar, and I guess I am your voice. So there's been a lot of discussion online about different technologies different energy generation technologies that might play a part in the transition, in particular, the role of fusion, which has been getting a lot of hype and investment, and people are curious about where you both see fusion actually landing, bioenergy, and Pedro, you brought up the potential growth you see in rooftop solar, but folks are interested in understanding sort of what's keeping that back right now, what are the economic challenges, and how does that move forward? So
Okay,
that was one
so
question.
maybe I'll
We
ask
have a lot of
Dave
pieces.
for some words on fusion, and then Pedro, what's holding back rooftop solar?
Sure. So I'm not a world expert on fusion. I do engage with several companies closely on that, and they're making tremendous strides. They believe their science is very predictable, and they would expect to see significant positive energy gains within the next, let's call it 3 years, and their aspirational target of on-grid in the first half of the 2030s. So those are bold claims from where they are, but they appear to be adequately financed, and their technologies that are approaching justify those positions.
Yeah, I think it's fair to say that there have been big bets made, bold bets made on fusion, basically in proportion to the size of the challenge of meeting renewable electricity demand.
And the interesting, a couple of interesting things is, which, me, I grade all these different energy sources based on, what cost are you going to come in at? The fusion guys have a view of a cost structure that's in the, certainly in the single digit and probably in the lower single digit dollar per kilowatt hour, right? Cent per kilowatt hour, sorry.
There's probably something like, what, at least 30 different startups right now?
There's a ton of fusion companies, yeah.
So Pedro, rooftop solar in California.
Yeah, so I'm not sure anything's actually keeping it back, because when you look at it, when California first started what's called its net energy metering program, which I'm guessing may be some of the comments you got online, rooftop solar cost 7 times more than it does today. Think about that. So the program has worked, right? You had big incentives that were set out.
Yeah.
The way the program works is that, for those of you who may not be aware, you get to essentially spin the meter backwards, right? You either use your electron, or if you have an excess electron, you can send it through the grid, and then you get paid at your full retail rate. Now, when you think about the electric rate, it's not just a generation component, right? There's the probably, few cents, 5, 6, 7 cents for generation in there. But then there's the cost of actually the wires. It's the cost of the customer service system and the, folks who send you the bill and maintenance, et cetera. And so really the generation component that rooftop solar is offsetting is probably, I'm going to say, less than a quarter of that total rate, but you're getting the full rate. So it's a really big incentive. So big that if you look today, and remember that's paid for by non-solar customers, just one set of customers creating the incentive for other customers. And it made a lot of sense initially to have a very rich program because the costs were so high initially, needed to give time for the technology to mature and become more cost effective. And also it was the early days. We wanted to stimulate that. Fast forward to today, like I said, rooftop solar is now 1/7 of what it used to be. And the subsidy from non-solar customers who tend to be less affluent to solar customers who have tended to be a little bit more affluent in California is over $6 billion a year. Mm-hmm. And so the program needed to be reformed. The California Public Utilities Commission did introduce some reforms that reduced the incentive for future projects. And we can get into more detail, but I'll just leave it at that kind of high level. And we think that was important to do because there's only so much money going around the system, right, from customers. And so I'd rather see those incentive dollars being redeployed, still having an incentive for rooftop solar. There's still one there. It's more right-sized. Let's take the other dollars and deploy them towards the next set of technologies that need to be 1/7 more affordable 10 years from now. Heat pumps, right? We need to send a demand signal to get heat pumps installed and bring that technology down in terms of cost. Batteries have come down probably by a factor of 10 in the last decade, but I'd like to see new chemistries beyond lithium-ion being incentivized. Some of the appliances, like electric vehicles, right, are getting good support to the IRA. So it really ends up being an issue of how do you redistribute limited dollars to have the biggest bang for the buck where you need it the most. And I would finally say that while there was before the cutover date for the new program, you saw a very dramatic increase in rooftop solar installations as people tried to get in under the more generous program. That moved a lot of demand forward. So in the first few months after that changeover, you did see rooftop solar installations decline significantly. But like has happened in every other market, they're back to their historical levels. So the market is still alive and well. There's just less subsidy going from customers to the companies.
So if I can add a question on there. So there is still a differential cost between utility grade solar and rooftop solar. If society is in the form of subsidies or whatever, going to spend some number, $1 billion, $10 billion, whatever, which one would you rather have them spend it on?
I don't think that we need the subsidy for most of the big central station technologies. Because again, today you see public announcements for central station solar under 3 cents a kilowatt hour, or under 4 cents with storage attached to it. So like I was saying earlier, I'd rather see the incentive dollars being spent on new technologies that are part of the whole value chain that need the help. And so again, it was heat pumps or next gen renewable technologies. Again, we were big fans of the IRA. It doesn't help our shareholders, right? Because those tax credits basically flow through our electric bill and make the cost of the transition more affordable for our end use customers by creating tax credits for solar, for storage, or for next generation geothermal. So that's where I'd like to see the dollars spent.
Cool.
Great.
Okay, let's take one more question right here in the center.
Yes, I got a question about the incentives. A lot of them, to me, doesn't make sense. Okay, for example, solar panel. I like to see solar panel to be used as roof of the house, so that I can reduce the cost of the house. And for example, using battery. There's a lot of electrical vehicles, so therefore we can charge the battery during the low hour and use it from 4 to 9. But however, the system costs $18,000. To me, it just doesn't make sense.
So the system costs that today. I think to Dave's earlier point, and to the point I was making earlier, it's important that we send enough of a demand signal to manufacturers so they can work on economies of scale and improving the technology to bring the cost down to a more reasonable level. And so that, from a government policy perspective, you deploy incentives where you want to move the needle somehow, right? So in the IRA, there's incentives being used there for used electric vehicle sales, right? To get that market moving. They should not be forever, right? Any incentive that's there forever is a bad incentive. An incentive that's there for a limited time period to help stimulate the technology to where it can stand on its own 2 feet, that's a better use of taxpayer dollars. Now, I juxtapose that need with the need to do something about climate change mitigation. Our planet is cooking, right? And we know we need these technologies deployed at scale to help bend the overall global temperature rise curve. The technologies, you're right, are expensive today. Deploying tax dollars to help more consumers buy down that cost and help manufacturers improve their cost positioning then allows society to actually get to the targets it needs to meet to get to a net zero world. So you really need to look at it in the broader context, and you really get into ultimately a governmental policy question. You're seeing economies around the globe deploying incentives to do that. Now, some do it more aggressively. I'd say the European economy was faster earlier on, and it slowed. It had more requirements. The IRA came in and changed the game, right, in terms of deploying tax dollars at that scale for technologies. Meanwhile, in the Chinese economy, you see significant support of manufacturing increases to not only for climate, but to actually build scale that can make them more competitive in the global markets. So you see different countries taking different approaches.
Yeah, okay. So let's see. I want to take one last question, and maybe from a student. Student? Okay, right?
So my question is about how do you see like a carbon tax? Is that necessary for avoiding global catastrophe in any way?
So I'll...
For the online audience, the question is, do you see a carbon tax as being necessary?
What's the unit of energy that the network should provide? Or I'm sorry, what's the unit of metric that the network provide? We can claim that the unit that you deliver us is a kilowatt hour, or we can claim it's a net zero kilowatt hour, or we can claim it's a equivalent to a cart decline, from your fleet efficiency declines, that you can say that on average, I've got a decline in carbon content to the energy block I defined. However, if you define what that commoditization metric is, and that all people need to compete on it, well, then the solar guy is going to be storage solar, right? And the natural gas guy, he's going to be carbon capture natural gas guy, right? Because that's the only way that you can come into an equivalent product specification that they have to deliver to, right? And that happens in all sorts of industries where you build in a fair playing field to accommodate the total cost. The solar guy needs to cover the cost of storage, right? The natural gas guy, he needs to cover the cost of carbon, and then go at it and compete on the marketplace in that definition. That's my opinion. That allows it, and I get to if the market is set up to incentivize the right behavior, people will invest the dollars most appropriately, and the investment dollars from the private sector dwarfs the investment dollars of the public sector. Get it to the point. Yeah.
So, Pedro, carbon tax?
I think it could be a good tool, and I think I agree with Dave's direction here. Look, ultimately, we do need a regulatory framework of some sort to account for this externality of the impact that greenhouse gases have on global climate. You can get there a few different ways, right? You can have a carbon tax. You can have a carbon emissions market. California has a carbon emissions market, but not for the entire economy right now. There are a couple of keys. You have to have it be defined well. It needs to be transparent, and it needs to be durable and long-term so that people can actually finance against it and invest against it. Mm-hmm. Carbon tax could be a real simple way of getting there, quote unquote, but politically today in Washington, it just doesn't have legs. Mm-hmm. And so that's that's the reality that we live with today, so I don't see a feasibility for carbon tax anytime soon. But ultimately, we need to make sure that we're, to your point, if you made me king for a day and you asked me how to do this, it could be a tax, it could just be simple, kind of a carbon market, but it has to cover the entire economy, and you can't be changing it every 4 years after the next election. It needs to be durable so you can invest against it.
Okay, great. So Pedro, Dave, thank you for helping us reimagine the energy system. So as we go, so it turns out that this is the WOOC lecture. WOOC was an innovator in electric vehicles starting in the middle of the 20th century. And so we have for Dave a commemoration of, and for Pedro, their participation here in the 2024 WOOC lecture. So.